Alright, we're going to do some more stuff with arithmetic sequences. If you haven't seen the previous video, I introduced the topic, so this video will basically be practice questions and other things you can do with these sequences in terms of solving. So we have a question here, and we're asked to determine the missing terms. Now, a lot of times you can sort of guess intuitively and get an answer. For instance, we see the difference between 8 and 14. We have two spots. They have to go up an equal amount in each step, and we can kind of guess it's going to be 10 and 12 because it fits the pattern. But let's do this without our intuitions, and let's show you how to use the formula here. So there's a key component in this, and it's a little bit unintuitive, so let me tell you what to do here. What we're going to do is we're going to pick the first number we see, and we're going to call it term 1. Now this might be counterintuitive since this spot right here, that's a blank, is term 1, but to make this formula work nicely, we're going to call this 8 our term 1. Then we're going to keep counting until we get to our last number here, and we're going to call it term 4. Obviously, if this was one more position over, you'd have to call it term 5, but you basically assume that the first number you see is term 1, and then you count and see what term this other number will be. And now what we do is we plug some stuff into the formula. Now the thing is, what are we missing here? Well, we know if our term 1 is 8, our A is going to be 8. What about our difference? What is that? Well, we don't know our difference. But what about our n? Well, we have Tn, and we have a T4 here, so our n is going to be 4, and we're going to solve for the difference. So let's use our formula here. We have T4 is equal to our A, our starting value, which is 8, and then we're going to add, well, we don't know what D is, so let's leave D there, and then we're going to multiply it by n minus 1. So this is going to be times 4 minus 1. So this will be 8 plus 3 times the difference. Now, we have a formula here, but we also have one more number that we can look at. And we know what T4 is. T4 is 14. So we can plug 14 into where T4 is. So what we'll have is that 14 is equal to 8 plus 3 times the difference. Okay, and now, with algebra skills, we will subtract 8 from both sides. So we will have that 6 is equal to 3 times D. And then we can divide by 3 on both sides to get that D is equal to 2. So we know the difference between each term is now going to be 2. So at this point, we can just fill in the blanks. We can find the number we have, and we can just add the difference in each case. So 8 plus 2 is 10, 10 plus 2 is 12, and 12 plus 2 is 14, so that's good. And now to go in the opposite direction, we just subtract the difference. So 8 minus 2 is 6. And now we have determined the missing terms. So, to do a step-by-step on how to solve this problem, step 1, you want to, well, this is step 2 here, is listing your terms. Step 1 is going to be picking your first term. And your first term is always going to be the first number you see in the sequence. Step 2, we're going to list out our starting value, where this 8 here, our A value, is going to be the first term that we picked. In this case, we don't know the difference, so we're going to have to find the difference. And our n here, this is going to be the second term you see. So in this case, this was term 4. So we put a 4 in here. Then, for step 3, you will write out your formula, and you will solve for the nth term. In this case, we're looking at the fourth term. And after this goes into the formula, you plug in all of your numbers listed in step 2, and you solve for d, and then you find the difference. And then for step 4, you fill in the missing terms. And then you'll be done the problem. And hopefully you got it right. So that's one type of problem you can have. In fact, I have another example here. So let's do this too. Step 1, we're going to pick our first term, which is term 1, and it's going to be 12. Now, what is the next number we see? Well, we see a bunch of blank spaces, but we see the number 22, and if we count how many spaces over it is, we find that this is going to be term 5. So now that we've picked our first term and some other term, let's list out what we know. Our a, our first value, will be 12. Our difference, well, we don't quite know that one yet. But our n that we're working with is going to be the fifth term. So our formula says that t5 is going to be the starting value, which is 12, plus n minus 1, so that's 5 minus 1, times the difference. Now what is our t5? Our t5 is 22. So we have 22 is equal to 12 plus 4 times d. Now when we subtract 12 from both sides, we're going to get 10 is equal to 4 times d. And then when we divide here, we see that d is equal to 10 over 4. Now this isn't a nice whole number. In fact, this is the number 2.5. And that's the difference. So when we plug in our values here, to go from 12 to the next number, we add 2.5, so this will be 14.5. We'll do the same thing to get the next term, so this will be 17, and we add 2.5 to get the next term, which is 19.5, and then when we add another 2.5, we get to 22. So the reason you want to do this with formulas is because it's not exactly obvious what you're supposed to do here. So hopefully with these examples, you understand this a little bit better, and the reason you should use the formula is because you can get some nice fractions if you are unlucky with your sequence. Which on a test, yeah, you're likely to get a fraction just to prove that you've done this formula. Alright, now that we've sort of filled in missing terms, we found general terms, we know how to find certain terms, what if I told you that some term was 333? And I asked you, well, which term is that? So what we're saying is that there's some term, Tn, that is equal to 333. But the question is, what is this n value? Which term is it? So we can solve for this as well. In fact, we know the formula. We know Tn is equal to a plus d times n minus 1. So let's fill in all the information we know. Well, what we're saying is that our Tn is equal to the 333. Our a value is going to be the first term here, which will be 8. And our difference is going to be the difference between 8 and 13, 13 and 18, and we see that we add 5 every time. And what is n minus 1? We don't know, so what we're going to do is we're going to leave this n minus 1 as a mystery, and we're going to solve for n. So let's do some expanding here. We see that 333 will be equal to 8 plus, let's distribute these numbers. This is 8 plus 5n minus 5. So we see 333. When we collect our 8 and our minus 5, we're going to get 3 plus 5n. Now we'll subtract 3 from both sides. So we have 330 is going to equal 5 times n. So when we divide 330 by 5, we are going to get that n is equal to 66. So this means that T66 is equal to 333. So this is 66 terms down this line in the sequence. We find the number 333. And we could find this just by plugging some numbers into our formula. Now here's an interesting question. What happens if I tell you to find a number that is not in the sequence? So what if I said, what is 332? What's going to happen is if I ask you for a number not in the sequence, is you're going to get n is equal to, in this case it would be 332, or sorry, this would be 329, I believe, over 66, but it'll be a fraction. And if your number is a fraction, then it's not in the sequence. So if you're asked, hey, is this number in the sequence? You can solve this formula, and if you get a fraction, you can say, no, it's not in the sequence. But if it is in the sequence, you know exactly which term it is. So that's kind of cool. Let's take a look at another type of question. There are so many types of questions you can do with arithmetic sequences, so let's finish off all the different types we can do here. Here's a good question. How many terms are there? We're given a first number, and we're given a last number. So we have a t1 and we have a tn. Now, I'm going to tell you a little trick here. This is the exact same question that I just gave you. I've just sort of masked the question because what this question is asking is what term is negative 245. Because when we know what term negative 245 is, we know what the last term is. And that number n will give us the amount of terms in the sequence. So let's solve for this. Okay. Tn is equal to a plus d times n minus 1. So we picked our Tn to be negative 245 because it is the last term here. And this is equal to the first term, which is 34, plus the difference, which seems to be, we have a minus 10, a minus 8, then a minus 10. I'm a little bit confused because this is definitely not a sequence here. So that's going to be 18, that's 9. I believe this should be a 25 here. So the difference is going to be negative 9. And then we're going to multiply this by n minus 1. So let's do some algebra here. We have 34. And now we're adding, we're going to distribute this. So this will be, we're going to add negative 9n. So this will be minus 9n. And then we're going to add negative 9 times negative 1, which will be 9. And this is equal to negative 245. So this will be 43 minus 9n is equal to negative 245. What we'll do is we'll subtract 43 from the left side. So this will be negative 288 is equal to negative 9n. And when we divide, we will see that n is going to equal 32. So negative 245 is going to be the 32nd term. So this is the 32nd term. And because negative 245 is the 32nd term, the whole sequence must have 32 terms. So it's kind of a trick question asking you the same thing, Of course, what it might say is, well, the series begins maybe at some other number. So maybe it doesn't begin at t1, it begins at t4. Then all you do is do the same thing. You just add however many terms you skipped the beginning to the end. So here's another type of question you can have. And again, this is determining the first term. So we're given some term way later in the sequence. So it goes a long way, and then we're given that 65 is the 17th term, and all we're given is that the difference is 4. But here's the question, what is the first term? So this can be, a little bit challenging, perhaps. But what is the first term? In our formula, we have Tn is equal to a plus d times n minus 1. What represents the first term? Well, the first term is represented by this a. So, what we're going to do is we're going to solve for a using the 17th term. So, what we have is that we have t17 is equal to a plus the difference, which is 4. So we have 4 times n minus 1. So this will be 17 minus 1. Now what is t17? We know t17 is equal to 65. So let's plug 65 in there. And this is equal to a plus 4 times 16. So 65 is equal to a plus 64. So a is going to be equal to 1. So our first term when we start out here is going to be equal to 1. So our series is going to look like 1, 5, 9, 13, 17, and eventually we'll get up to 65, and this will be the 17th term. And of course you can check this for yourself. You can add up all the numbers and go through the series until you get to 65. Or you can think of it kind of like this, and I'm going to do this to wrap up sort of the idea of what the formula is doing. So we start at 1 here. Now, we're adding 4 times some number to get to 65. Well, basically what we're saying is 4 times some number is equal to 64, so when we divide, we see n is 16. So what we know here is that we're going over 16 positions, and 1, the first position, plus 16 more positions, is the 17th position. Therefore, really, we're just taking the first term, adding the difference between all these terms, and getting to 65. So that's sort of the intuition behind the formula. It's a good reminder of what you're doing here, seeing the big picture. And really now you're able to solve pretty much any question you need to, and hopefully. Of course, you can do some more practice problems, always good. Got to do a lot of practice problems to really solidify the concepts and stuff, because you may know it now, but on a test, if you don't practice, it'll be a little bit difficult. And of course, if you have some harder calculations, the numbers aren't always as nice as they are here. So when you see weird numbers on a test because you're using a calculator and you're thinking, hey, hold on a second, I've never seen anything like this before, you might still be doing it right, but you don't have the practice to guarantee that. So let's do a word problem here. We're told that each triangle has a side of length 1, and we want to find a formula for the perimeter of these triangles, where our T1 is one little triangle, our T2 adds a layer, our T3 adds another bottom layer, and it keeps going on. And then we're asked to find the perimeter of the 15th triangle. So, how do you do a question like this? We need to identify a few things here. We're told that each side has a length of 1, so let's just kind of write this out here. So we have a 1, a 1, a 1, and of course we're looking for the perimeter, and the perimeter is the length of all of the edges on the outside. So if we do a little chart here, we do a term chart and a perimeter chart, then on our first term, we have a perimeter of 3. Now what about on our second one? Well, the perimeter is this outside edge here. And this is made up of little triangles. So we have 1, 1 here. We have another 1 and a 1 on the right. And we have another 1 and a 1 on the bottom. So this has a nice perimeter of 6. So our second term has a perimeter of 6. Just to make sure we're doing this right, these triangles all have sides of length 1. So if we go around the triangle, we see that this has a perimeter of 3 on each side, which is going to be 3 plus 3 plus 3. So this will be a perimeter of 9 for the third term. And we want to find the perimeter of the 15th term. So we actually have a sequence here. The sequence is 3, 6, 9, and it goes all the way up, and we want to find the 15th term. So how do we do this? Well, all we're looking for is T15, which we know is equal to A plus D times 15 minus 1. So let's plug some numbers in. Our first term is going to be A, which is 3. Our difference is going to be, well, we add 3 for each term, so our difference is 3, and 15 minus 1 is 14. So we have 3 plus 42, and our 15th term is going to have a perimeter of 45. So the triangle that corresponds to 15 rows, its perimeter will be 45. So again, this is a word problem where we just draw a picture, analyze some stuff, we make a nice little chart, and then we get a sequence out of it, and we can solve basically whatever we want in this sequence. So when you do this stuff, you have to sort of take the question and figure out, okay, in this question, what is the first term? Because the first term is the most important part. Then the second most important part is saying, well, what's the difference between the terms? And once you have the first term and the difference, you can solve for anything you want. So that was all of arithmetic sequences. Hopefully this wasn't too bad. You should do probably a lot more practice problems if you're doing this in a math course. You have a textbook, so do the assigned problems. It's a really simple concept to get you guys 90% pluses in your courses, because people who do practice problems ask questions like leaving them in the comments if you have any questions, and talking with their teachers. You can get 90% in these courses, no problem. You just have to focus, learn. If these videos are not doing it for you, find other videos. There's more than one way to learn things, and somebody else may explain this a little bit more differently than me. So, because this is the beginning of the course, I'll give you this advice now. But for most of you, this is the last math course you're ever going to take. And I will tell you this stuff is useless in life until you go on to further mathematics, but what isn't useless is learning this. Because math has this really cool thing in your brain, somewhere in your brain, that teaches you logic, and it teaches you how to think. So when you learn math, you're learning some very important things for your brain. So stick with it, try hard, and if you have any questions, as always, leave them in the comments below, and I'll get to them as quickly as I possibly can.